In the other videos, I described mean and median, and in this video, I'm going to talk about mode. So a good thing to start with mode is to talk about discrete versus continuous data. So discrete data can only have certain values, and typically we're talking about whole number values. So a number of people or a count or a vote, something like that. Whereas continuous can have in between or fractional values like height, weight, time, distance, etc. With discrete data, for example, when I'm counting people, I cannot have half of a person, for instance, whereas with weight, I could have half of a pound or any fractional part of a pound. So this distinction is very important when determining which measure of central tendency would make the most sense in a given situation. So let's look at mode. I have a survey here. How many siblings do you have at home? And we have some different options, 0, 1, 2, 3. And then I have the number of students responding. So here, with how many siblings do you have, the mean and median values could be fractional parts. So if I'm taking the mean number of siblings, then I could be getting a fractional part of siblings, such as 2.1. Same thing with the median. I can get a fractional value for that because that's the way that median is calculated. However, saying that most people have 2.5 or 2.1 siblings doesn't make a lot of sense, given that you cannot have a fractional part of a sibling. So a better answer for what number of siblings do most people have would be 2, because that is the most popular value. 16 people said that they had 2 siblings, and fewer people said they had the other numbers of siblings. So this is mode, where you're finding the most frequent or most common data point in a set. Let's look at another example. So reviews for this 6-pound bag of gummy bears. The average or mean review is given there, 4.7 out of 5. However, 4.7 is not a rating that you can actually give the gummy bears. You can give it 1, 2, 3, 4, or 5 stars. So if I'm looking at the mean here, I'm looking at a data point, 4.7, that does not actually exist in the rating system. If I'm looking at mode, though, I can see that most people gave this bag of gummy bears a 5-star rating. So in this case, the 5-star rating for 85% of people giving that one makes more sense for me to use when I'm determining whether or not to purchase this bag of gummy bears. The 5 is the mode. That's the most common data point in this example. Mode is also important to think about when you're talking about a bimodal distribution. So we don't talk about bimodal distributions explicitly in 6th grade math, but it's important to think about when you're trying to determine what measure of central tendency to use. It does not always make sense to use the center of the data set. So here I have this graph, and you can see the center would be here. So in a bimodal distribution, you don't have very many values in the center. You have values that are bimodal, which means they're congregated around 2 other points. All right, so let's look at some examples. So if I was trying to take the average cost of a book, you have, on one hand, you have paperback books, which are much less expensive, and hardcover books, which are much more expensive. If I'm taking the average cost, then I'm talking about a cost that is probably not an actual cost of many books. Okay, so if the average cost of a paperback book was $10, but the average cost of a hardcover book was $20, it wouldn't really make sense for me to say the average cost of a book is $15 when there are not many books that are actually that cost. Okay, same thing with restaurant attendance time, lunchtime versus dinner time. If we say the average time or the busiest time of arrival at the lunch for a lunch at a restaurant is like 1 o'clock, and then for dinner, maybe 7 o'clock. If we were averaging 1 and 7 and getting a time in the middle, like 4:30, that's not a time when probably anyone is at the restaurant. That would be a rare time. So saying the average doesn't really accurately describe the data there either. Same thing with speed limits, residential versus highway, life expectancy, and then I have some elephant seals here. So if I'm trying to tell the average size of an elephant seal, and I'm just averaging all of the sizes of every seal, regardless of if it's a male or a female, then what I'm coming up with is a number that doesn't describe any seals. So that's what I mean when I say a bimodal distribution, which is to say that sometimes mean and median are completely meaningless statistics, and mode is the most important statistic. So in a bimodal distribution, there's two modes or two most common values that are different from each other. Okay, so mean and median don't make sense there. So the advantages of mode is they will be a real number. Like in the rating example, if you're thinking, okay, it's got a 4.7 star rating, then you can say that's close to 5, but you know that 4.7 is not an actual rating that anyone can give. So the mode 5, that is a real number in that it is represented in the data set. It's useful for discrete data. However, not every data set has a mode, and it's not helpful when data is continuous. So if I'm taking weights of 100 people, it's not very likely that 2 people would have the exact same weight, especially if we're measuring out to the 10th or 100th place value. So that wouldn't really be helpful at all if I'm talking about continuous data.